Alright guys, so we're just looking at question 2. We have a square-based pyramid, and the dimensions of the base, obviously it's a square, so if one side is 8 meters, then the other is going to be 8 meters. Just bearing in mind right away that 8 meters is the same as 800 centimeters if we require this. Now we're told that the vertical height of the pyramid is 3 meters. At this distance here, let's say AB, let's look at that distance here. The length of AB is 3 meters, or it's the same as saying 300 centimeters if that is required. Okay, so we have the dimensions of the pyramid. So the first thing they're asking us to do is to find the volume of the pyramid. Okay, so we need to find the volume of the pyramid. Now, the volume of the pyramid is a third times the area of the base times the height. That's the volume of the pyramid. And it's a third, and the area of the base, it's a square, so it's going to be 8 times 8. That's the base, and the height is in fact 3 meters. Okay, so this is a third. 8 times 8 is 64. So what we have here, this 3 can cancel this one. So we have a volume of 64 meters cubed. So the volume of the pyramid is 64 meters cubed. Okay? Now, I'm just going to put that aside here because what I want to also emphasize is the volume in centimeter cube if we require that. So again, this is 800 times 800 times 300. All right. So again, this represents the base, and we're dealing with the volume now in centimeters. All right. So we're just dealing with this. So what we would have is right away this cancels this, as in fact 3 go into 300 100 times. So what we have now is this would be 640,000 times 100, which would be 6400, and we add those 4 zeros, cm cube. So 864 and 1 2 3 4 1 2 3 4 times 100, we have 1 2 3 4 5 6 1 2 3 4 5 6. So this would be this looks like 64 million cm cube. All right, so we have the volume in meters cube if we need it, and we have the volume in cm cube if we need that as well. Okay, now what they asked us for next is the capacity. Now they're asking us for the capacity in milliliters. All right, capacity in milliliters. All right, so we have the capacity in cm cube, so the capacity will be 64 million milliliters, and that will be the capacity. All right, so we have that sorted out. The next thing they're asking us to find is the surface area, the total surface area. All right, they're asking us to find the total surface area. Now, the total surface area, let's get to the net quickly. Square is the base, and that's 8 by 8, and we're asked in part D as well to show the height of each of these triangles. Now, there's no way we can find the total surface area unless we have the height of these triangles here. So the good thing about it is that the dimension or the base, dimension for the rectangle, sorry, for the square is 8 by 8. So if we find the height of one triangle, because the bases are the same, if we find the height of one triangle, then we're going to find the height of all the triangles. All right, so if we look back at the original diagram, here, you notice that I've put in a triangle here in pencil, and if I can find the hypotenuse, that would actually be the perpendicular height of the triangle, the slanted triangle or the lateral triangle. So what we can do is just utilize Pythagoras' theorem and just find that half of 8 here would be 4 meters, So if I can find the length of the hypotenuse based on these two values, then we can have the height of the triangle. And if I know the height of the triangle of one of the lateral sides, then I know all of them because of the fact that the base is square. So let's try to deal with that. So hypotenuse, which in fact represents the height of the slanted triangle, equals the square root of 3 squared based on this fact, and 4 squared. So that would be 4 squared there. Alright, so this would be the square root of 3 squared is 9, 4 squared is 16, and that's 25, and that would be 5 meters. So the slanted height of each triangle here is 5 meters. So we know the height of each triangle. So it's easy now to find the area of the slanted triangle. That would be simply half times base times height, and that is going to be half. The base in fact is 8 meters, that's clear, and the height is what we found to be 5 meters here. This line will represent the height of the triangle in question. Okay, so it will be half times 8 times 5. So what we have now, half of 8 is 4, and 4 times 5 is 20 meters squared. So we actually have the area of one of the slanted triangles, and because we know that the dimensions are the same for all, and there are 4 triangles, you just need to find the area of all triangular faces. Right? So that would be 4 times 20. So the area of all triangular faces would be 4 times 20, and that would be 80 meters squared. Now, area of base, seeing that that's a square, that would be 8 times 8. As a matter of fact, we found that out already. 64 meters squared, the area of the base. Okay? So the total surface area would be 64 added to 80. 64 added to 80 would give us 144 meters squared. That would be the total surface area of the entire square-based pyramid. And for part D, we can just put in the heights. That's what they're stressing on, the heights of each of these triangles, and we found it to be 5. So this would be 5, and that would be 5 meters, that would be 5 meters. So we're just indicating that is the perpendicular height of each of the triangles there. And that would have been question 2. Alright, now let's see if I can get question 3 out of the way quickly as possible. So we're finished with this. Question 3 should be short. Let's just deal with that quickly. It says, the base of a triangular based pyramid has dimension 697 centimeters. So let's just put that on quickly. Question 3 are told 6 centimeters, 7 centimeters, and 9 centimeters. So all they're asking for is the area of the base, which is the area of this triangle. So of course we have the lengths of all 3 sides, so we can go ahead and find the semi-perimeter. 9 plus 7 plus 6 divided by 2, that is 9 and 7, 16, and 16 is 22 over 2, that would be 11. Okay? 16, 22, 22 divided by 2 is 11. So the semi-perimeter is 11, so the area of the base, which is the area of the triangle, simply would be the square root of s times s minus a times s minus b times s minus c, which is the square root of 11 times 11 minus 9 times 11 minus 7 times 11 minus 6. So this would be square root of 11 times 2 times 4 times 5, which is the square root of 11 by 2 is 22, and 88, and 88 by 5 is 40, it's like 440. Just working out on my head here, though, the calculator in my hand. So let's double check that one. I grabbed the calculator, see that's 440 for me. And square root of 440. Let's just double check this. So we have 11 times 2 times 4 times 5, 440, and the square root of 440 would be 20.98 centimeters squared. So the area of the base, so the answer for question 3, given that the base of the triangular base pyramid, that's all that they ask us to define the area of this triangle. And of course, when we have the length of all 3 sides, we just apply Heron's formula, find the semi-perimeter, which is 11, and then go ahead and find the area of the base, which worked out to be 20.98 centimeters squared. So I hope you guys found the video insightful, and give me some feedback. All right, see you guys on the next video.